Hello, student. The question says, in a human pyramid in a circus, the entire weight of the balanced group is supported by the legs of a performer who is lying on his back, as shown in figure 8.4. So this is the figure that is given in the NCERT, and you can see this is the whole group, and this entire weight is placed on the legs of the performer. So these are basically the legs of the performer on which the entire weight of the above thing is balanced. The combined mass of all the persons performing the act. He has given all the persons performing the act is 280 kg, and mass of the performer lying on his back at the bottom of the pyramid is 60 kg. This is the tricky part in this question. He has given combined weight of all performers, all performers is equals to 280 kg. See, when you say all performers, it includes the person balancing the entire people also. Like that means it includes the weight of the performer that is lying on his back. Like in the figure, I can clearly see there are 1, 2, 3, 4. There are 4 performers. 1, 2, 3, 4. So all the 4 people weight together is 280 kg. In that, the person that is lying on his back is 60 kg. So combined weight of all performers 60 kg, 280 kg, and person on back 60 kg. If I assume that the performer need not balance the weight of his legs also, then we can tell the performer must balance 280 minus 60 kg weight on his leg. That means he has to balance 220 kg weight. The remaining 1, 2, 3, the remaining 3 people are 220 kgs. So he has to balance those 220 kgs on his legs. Each thigh bone, and we have 2 legs, and in each leg, each thigh bone of the performer has a length of 50 centimeter and an effective radius of 2.0 centimeter. Determine the amount by which each thigh bone gets compressed under this extra load. Okay, he has given thigh bone of this performer has a length of 50 centimeter and a radius of 2 centimeter. So you can see what is the meaning of thigh bone, like the femur that he's talking about. These bones. So he's telling they have a length of 50 centimeter and they have a radius, like effective radius we can take. They have an effective radius of 2 centimeter. Because you can see the radius is not uniform, so we will take the effective radius as 2 centimeter. Now, how can you reimagine this entire question? The entire question that is given to us, we can reimagine this entire question as we have a table where a mass of 220 kg is present. And this 220 kg must be balanced by 2 rods. That means each rod must balance how much weight? It should be 110 kg. Now the question is why it is 220 and not 280. As I explained, we will assume here that he need not balance his own weight, which is technically slightly wrong. When a person is balancing so many people, he has to balance the weight of his legs also. So his weight of the legs also would fall on his legs only. But here, since this is an example problem, so NCERT assumed that he need to only balance the remaining weight 220 kgs. So we can reimagine this entire question as in this way. So once we understood this, we know he is asking us to determine the amount by which each thigh bone gets compressed. So to do that, that means we need to find change in length in each thigh bone. We know the formula is Young's modulus of elasticity is equals to stress by strain, stress divided by strain. And in place of stress, I can write force per unit area divided by change in length by original length. So take this to the other side. Change in length by original length is equals to F by Y into A. So change in length would be F into L by Y. So we need to find on each thigh bone. What is the force balanced by each thigh bone? So total we are balancing 220 kg. So each force on each bone would be like mass on each bone into G. We know total 220, each bone is taking 110, 110. So mass on each bone is 110 into G value. I will take it as 9.8 because in the example also, it has taken it as exactly 9.8. So if we try to do that, the force on each person would be equals to 110 into 9.8, which would be 1078 Newton. So we got force. Then length of the bone. The length of this is given as 50 centimeter in the question. So length is 50 centimeter. So I'll write 10 power minus 2 meter. I got length. Now area. So area, if you assume almost it's a circular one, effective radius. So we can call it as pi into r square. So pi into the value of r given in the question is 2 centimeter. So 2 into 10 power minus 2 whole square. So 4 pi into 10 power minus 4 meter square. This is area. Now, once we have all this, then we got F, L, A, but I don't know the value of Y. So we can get the value of Y from the chart that is given in the NCERT only. He has given Young's modulus of various materials. If this question is ever asked in examination, he will give you the values also. You no need to worry about it. So it is in 10 power 9. So 10 power 9, Y is in 10 power 9. So for a bone, it is 9.4 into 10 power 9. Since it is 9.4 into 10 power 9, so let us take that value. So Y equals to 9.4 into 10 power 9 Newton per meter square. Now substitute everything and we'll get our answer. From this, delta L equals to force value is 1078. L value is 50 centimeter. Y value is 9.4 into 10 power 9 into area of cross section is 4 pi into 10 power minus 4. So if I take these terms 1078 into 5 divided by 9.4 into 4 into pi into in the numerator we have 10 power minus 1. Here 9 minus 4 is 5 when it goes to the denominator minus 5. So let us do this in the calculator to get what's the value. 1078 into 5 divided by 9.4 into pi into 4. So you will get basically 45.63 into 10 power minus 6 meter. So this is the value that we are going to get. If you want in centimeter, we can write 45.63 into 10 power minus 4 centimeter, because anyway 10 power minus 2 I can write into 10 power minus 4 meter. 10 power minus 2 is nothing but centi. So this will be its value. In the NCERT, it is given as delta L equals to 4.563 into 10 power minus 3 centimeter. So approximately it is given as 4.55. Since we solved this value, this is what we got. We can even find what is the fractional change in length. If you want to find what is the fractional change in length, for fractional change in length, we'll do delta L by L into 100%. If I try to do that, delta L by L 4.563 into 10 power minus 3 centimeter divided by length also we'll substitute in centimeter only, 50 centimeter. I'm not writing 10 power minus 2 because both I want to substitute in centimeter into 100. So basically this is 2. If you do it, you will get 4.563 into 2, which is 9.126 into 10 power minus 3 percentage, because we have this percentage. So the fractional change in length in this problem is roughly 0.0091%, which is extremely small. This is such a small percentage, it may not damage his bones that much. So this is the performance, but practically, as I told you, these won't experience the force. These will experience his own weight also, number one. And it's not like they are at an angle also. Since they are at an angle, it won't be this simple. Since these legs are at an angle, we have to again resolve it into components and we have to do it. But since this is an example problem, so we can understand how are we supposed to solve this. But the most important takeaway from this problem is that he has, look at the English sentence he has given, the combined mass of all the persons performing the act, all the persons involved in the act is 280. That means it includes the weight of the performer also. While solving the problems, you have to remove his weight, 280 minus 60, and you should take 220. This is the key step in solving the problem. Hope you understood how I have solved. Thank you.